Today's video describes agent management. This is part 7 of a 14-part series. Hello, I'm James Helfrich. We're all very familiar with using human agents to do work, as well as software agents. But AI agents introduces a whole new class of help. This video describes what is an AI agent and how it can be used to maximize the productivity of individuals in the workplace. There are many different types of information workers in this world. An architect, a developer for code, an author for books, a lawyer, a business analyst, an accountant, a banker, and a marketing agent. Now, each of these has some similar characteristics and, of course, some unique things. We're going to focus just a minute here on the architect. Usually, for an information worker, there are three distinct types of roles. The first one is the manager who directs and manages the content creation process. And this is true, of course, for all the different information workers we discussed. And then there's the contributor who executes the manager's vision. And finally, we have the technician. And this varies wildly according to the different discipline. It could be the draftsman who actually draws the drawing. It could be the paralegal who runs the case studies for the lawyer. It could be the teller who actually carries out the transaction for a banker. There's a wide variety of different things. And traditionally, how this was done, let's say 50 years ago, you'd have a collection of contributors, but you'd also have a technician who helped with the mechanical parts of the work. And this was all orchestrated by a manager. So let's take a look at the architect. We have the principal architect who has the vision for the project and who orchestrates the work to be done. We have the architect who actually does the pieces of the work, and we have the draftsman who assembles this. So going back to our circle, we have the principal architect who orchestrates the work. We have the various architects who carry out the action. And then, of course, we have a collection of draftsmen who mechanically create the drawing. Now, this changed with the introduction of software, and this is how things were done, let's say a couple of years ago. We would have an AutoCAD who would replace the draftsman, and then we have the architect and the principal architect doing their same role. So going back to our three circles diagram here, now we'd have a collection of architects. We don't have draftsmen per se anymore, but we have AutoCAD that is run by the architect. And then we'd also even have AutoCAD that's run by the principal architect. So now we can see how software agents have helped with this work. What's this going to look like in a few years' time, or perhaps even today? Then we're going to have the architect who, once again, manages the process. We're going to have an AI assistant who carries out the minutia of the detail. And of course, we'll have a software agent like AutoCAD, which is going to actually carry out the work. And so the role changed a little bit now because the architect works in the role that the principal architect used to. And then they're going to have AutoCAD as a software agent. We're going to have other architects they collaborate with. And now we're going to have AI agents to perform some of the work. Or more generically, we're going to have an agent manager who is going to work with software agents, human agents, and AI agents. And these different types of agents do different types of tasks. Effective AI management is the process of taking a large task and breaking into small ones and delegating that small task to the human, the software, or the AI whenever it's best at. So let's start with a human agent. And this is the default choice in most scenarios, and basically it's all we had for thousands of years of time. And what are the strengths of human agents? Well, they're social. Humans can read subtle social clues, respond in contextually appropriate ways, and form interpersonal bonds. When a problem requires strong social intelligence, humans remain the best choice. And there's the physical aspect. Some tasks require physical context, meaning they involve interacting with physical world in non-trivial ways. Surgery, construction, even cooking demands levels of dexterity that machines cannot currently match. Then we have the ethical aspect. Many situations involve value-based decisions, particularly where values conflict. This is especially true in contexts involving legal, moral, or professional liability. And finally, humans are really good at creativity. AI and traditional software systems can certainly generate creative output, but humans excel at drawing insights from lived experiences in a way that AI cannot fully replicate. This capacity is often described as intuition, instinct, imagination, or even vision. Now, of course, human agents have a few weaknesses. The biggest is perhaps bias. Human judgment is often influenced by racism, discrimination, prejudice, and other forms of bias. As a result, it can get difficult for one person to objectively assess another. Humans get bored, and when they do, often take shortcuts. This tendency is especially pronounced in tedious and repetitive tasks. there's the precision aspect. Related to boredom, human performance often degrades due to fatigue, distraction, and emotional factors. Humans take a long time to perform simple mathematical calculations and make decisions and generate text. And finally, software vastly outperforms humans on well-defined but highly complex tasks. Humans can track only a limited number of variables, calculations, and dependencies at once. So you can see that human agents have strengths and weaknesses, which we're well familiar with. Let's contrast that with software agents. One of the strengths of software agents is their precision. If a software can perform a task once, it can repeat it indefinitely with zero deviation. This guarantees correctness and deterministic computation that AI and human agents just cannot match. Software agents are super fast, latency often measured in extremely small fractions of a second. AI agents can typically require far more computational resources to complete comparable tasks, and humans cannot operate anywhere near these timescales. The task cost is a function of direct hardware expense, energy consumption, and human wages. The cost of completing a task is significantly lower for software than is for AI, and incomparably lower than for human agents. Software is capable of running simulations, performing complex calculations, and storing far more data than humans could ever manage. AI agents can perform complex tasks, but they cannot yet handle the level of computational complexity that dedicated software systems can achieve. Traditional software is unmatched with its ability to store and recall facts. Computers do not forget, can maintain vast collections of data, and can retrieve that data almost instantly. Human and AI agents cannot compete with software agents in this regard. And finally, traceability. Every number in a response and every pixel on a screen can be traced back to the algorithm that generated it and the data from which it was derived. This yields a level of provability and accountability that human and AI agents just cannot match. Of course, software agents have weaknesses, and the first of which is creativity. Traditional software systems can only do exactly what they are programmed to do. Any creativity expressed by software originates in the algorithm designed by its developers. In other words, creativity occurs at programming time, not at execution time. Software agents can handle only data they are explicitly programmed to process. Even small deviations can result in task failure. This places the burden on programmers to anticipate all possible input combinations, an extremely difficult challenge. Human and AI agents, however, can adapt to unexpected data on the fly. Writing code is expensive and error-prone. It is often much easier to teach a human how to perform a new task than to program a computer to do it. And finally, traditional software lacks the semantic understanding and contextual awareness that humans have. In other words, software is incapable of understanding the same way humans can. Okay, taking all these things into account, let's see how AI agents fill into this niche. The first of which AI understands. AI agents model patterns that correlate with meaning, interpret linguistic nuance, and make sense of information in structured ways. These representations can produce behaviors and responses that resemble aspects of human intelligence. In other words, if a human can comprehend it, then so can an AI agent. LLMs are really good at pattern detection. They detect correlations, structures, and anomalies in data. This capacity applies to speech patterns, visual patterns, and many other types of structured and even unstructured data. Traditional software generally requires structured data, but AI agents, by contrast, can ingest raw, messy, incomplete, and ambiguous data. AI agents can adapt and learn on the fly, much like human agents. Traditional software, by contrast, acquires new skills only when it is explicitly programmed to do so. And finally, AI agents never get bored or impatient. So what are the weaknesses of AI agents? Well, number one is determinism. Because LLM response generation is inherently probabilistic, some responses may not follow a given prompt twice. In scenarios that require a high degree of predictability and repeatability, this is kind of unacceptable. Any notion of ethics or morality with an AI originates in the training data and the alignment procedures. It is difficult to ensure that an AI agent consistently conforms to the values required for each context. Furthermore, when a problem requires nuance or a decision in the face of ambiguity or conflicting moral considerations, AI agents can behave unpredictably. AI agents can recognize and interpret emotional clues, but they do not process emotions themselves. Thus, situations requiring genuine human empathy and trust are better left to humans. LLMs do not store or retrieve facts the same way traditional software agents do. In other words, their level of memorization is comparable to a human, which, let's be honest, is not that great. And finally, LLMs are notoriously unreliable at mathematical computations. Most modern AI agents circumvent this limitation by delegating computational tasks to external tools, such as software agents. Okay, so let's bring us back to this whole thing here. We're going to have an agent manager who coordinates the work between humans, software, and AI agents. And remember, humans are really good at social, physical interaction, ethical considerations, and creativity, but we have problems with bias and boredom and speed and complexity. Remember, the software agents are really good at precision and speed and cost and complexity and memorization, especially, and traceability, but creativity, not so much. They can't handle unexpected things. Their training costs, namely programming, is high, and they just don't understand. And finally, AI agents are really good at comprehension and pattern recognition and dealing with messy data and learning on the fly and super patient. But determinism, not so great. Ethic and emotions, better leave that to humans. Memorization and computation, software is way better. So here's the key point here. The synergy between human, software, and AI agents is key because working together, they could do far better than anyone can by themselves. The trick to AI management is using the right tool for the right job, is understanding the strengths and weaknesses of each agent and leveraging them to the maximum effect so you can solve your problem in the best possible way. There are four activities central to agent management. The first is orchestrate, and is take a large and complex problem and break it into manageable chunks. The second is to delegate, give a subtask to a direct report, a human, software, or AI agent. The third is to evaluate, in other words, ascertain the quality of the work to see if it is fit for use and what needs to be done to improve it. And finally, to redirect, give necessary instructions to increase the quality of the work to an acceptable level. Okay, let's talk about each one of these in turn. So, first of all, to orchestrate. First of all, you have to have an idea of what the solution process looks like. Sometimes it's as simple as step one, step two, step three, step four, but oftentimes you know there's junctures. You have decisions you have to make. You're going to go through three or four different scenarios, see which one is best, choose from it, move on. An experienced manager understands the roadmap, the path to success, and all the different permeations it can take and can navigate this path. This requires the agent manager to have the 30,000-foot level, to have the big perspective, to not get bogged down in the details and understand the direction we're going. The second part of this is to integration. Once we've taken a little subtasks that we delegated to various agents, we got to bring it all back into a single unified whole. All this is part of the orchestration process. Now, delegation. An important part of the delegation is to assign a task to a direct report. And this is true whether it's a software agent, AI agent, or it's the human agent. You have to be very specific. You have to be very clear about what the requirements are. You have to make sure there's no possibility for ambiguity. And most importantly, you have to make sure that all the background information is present. In other words, prompt engineering comes into play. Now, of course, once a task has been delegated, you got to get a report to see whether it's fit for use. And you have to ask for that report specifically. In other words, you have to ask for the information you need to make an informed decision whether this delegation worked. And this brings us nicely to evaluate. Evaluate is all about requesting that report and in the format that you need and making an informed decision based on proper metrics. In other words, we have to make sure that the metrics are valid, that we're measuring the right thing, and that they're reliable. There's a small amount of error in the measurement. And if we have these high quality reports and make the decisions based on the metrics, then we can evaluate the quality of the delegation appropriately. And of course, not always is the task going to be carried out the way you hope. And so you need to give that direct report. Once again, whether it's a human or AI agent, specificity about what needs to be done to improve it. And of course, clarity. This is exactly what needs to be changed, and this is exactly does not need to be changed. If we master all of these skills, then we can be effective managers. Now, I need to emphasize, managers of human agents 20, 40, 50 years ago did all of these things. The difference is that now new hires, people fresh out of college, need to master these skills initially. This puts a whole new emphasis on this higher order of thinking that was just not needed for college graduates in years past.